These sockets here on the digital multimeters are for the ammeter, and I'll be showing you how to use that to test both AC current and DC current with the digital multimeter. I believe by now you must have known how to use the DC voltage meter and the AC voltmeter. If you don't know that, you can check my previous video and make sure to give me a follow. Save this video so you can find it later, and make sure you also share it with anybody you know it can be useful to. So to use the current meter, which is called an ammeter, it follows a different procedure unlike the voltage meter. If you remember, at the start of this series, we'll have the common. Let me unplug this probe so you will see it. We'll have common. This is where the black probe will go to. Let's plug it in. And now we'll have red, red, red. So if you look closely on this first red, you will see V, which is for voltage. You will see ohms symbol here, which is for resistance, which is this meter you have over here. You would also see HZ, which is representing frequency, which is for this frequency meter we have over here. You also see this temperature for temperature meter. You also see capacitor diode. So this particular socket is for all these meters. You are seeing the symbols here. And on this side, you will see A, which is for amps. And you can also see this is microamps as well and milliamps. So these two sockets are for the ammeter, both for DC and AC ammeter. And I will show you how to use the DC one on this video. On the next video, we are going to do for the AC ammeter. So the current we want to read, we don't know exactly how big or small it is. So I'm going to be using the biggest one. This meter can only read from 10 amps below. So we'll have the red probe on the ammeter, and we'll now switch the meter to A. So on this auto read, you notice that the A is for both DC and AC. It has both symbols. So when you put it here, you look at the screen. This is ammeter here, and this is DC. So from the select button, you can even change it to AC. It is now AC ammeter. Here now it is DC ammeter. Since you're already DC ammeter, we are going to leave it at this position. And on this other meter, it is straightforward. Not really. Let me also show you if this is the type of meter you have. I think I have a better meter, a better marking that will make it easier for you to see. I think this is more better. Yeah, this is clean. So let's use this instead. So if you look, where is the ammeter of this one? So you have two sections. You have the orange and the yellow parts, and you also have the white parts. Hold on, let me position this properly so you will see them. So we'll have the yellow part for AC. You can see the symbol here, ACA, which is ammeter. And you have another ammeter for the DC. You can see the ranges. So depending on how many currents you are to measure, you put it on that position. So let's say we are unaware of the current, you can always put it to the highest one. Now we want to measure DC current, you switch it to the maximum, which is 20. So we are at 20 amps currently on this meter. Then you remember we put the probe at the common and also the maximum here. You can see max 20 amps. So this is where the red probe will go to. But since we are testing with our auto range multimeter, we are going to stick to this. So for this test, I have a lithium battery with me, and I have the voltage booster as well. So what I will do on this video is we're going to be checking the current being drawn from this battery, from this voltage booster. Then we're also going to put some load on the voltage booster to see how many current it is taking, or how much current it is taking from the battery through this meter. So to do that, now you need to understand something. If we are testing for voltage and some other parameters, the probe goes in parallel with the terminals. But for current, it is in series. Let me explain. This is a voltmeter and this is an ammeter. So for the voltmeter, let's say you want to check the voltage of a battery, like we did on the previous video, or you want to check the AC voltage from the extension from your power supply, that's in your household, your socket and all of that. For the AC meter, it is very straightforward. The terminals are going in parallel with what you are testing. For example, we have a battery. This is the symbol for battery in a circuit system, and we want to check the voltage of the battery. You just take the probe of the meter, right? This will be the positive probe and the negative probe. straight to the two terminals, and this way you can read the voltage of the battery. You could be getting 3.7 volt, for example, for the battery voltage. But when you want to read current, because current and voltage does not behave the same, voltage is always available whether demanded or not. The voltage is available, but for current you have to demand for current before current will flow through a closed circuit. Voltage, even if the circuit is open, voltage is present, but for current it is what you are demanding that you are getting. Voltage is available every time. When you come, you see voltage, but for current you have to demand for it, and it is the amount of current you demand that will flow towards what is demanding it. And that's where, if the cable is not sized appropriately, when you are not demanding much current, the cable will start heating up because it is not able to carry the amount of current you are demanding through that circuit. And because of that, the ammeter behaves differently from the voltmeter. So for the ammeter, when you want to read, you don't read it the way you read the voltmeter. You understand? First of all, you don't just put, let's say you want to check the current in a battery. You don't just put it directly on the battery this way. That will be bridging the battery. Let's say we have a load, a light bulb for an example, and we want to see how much current that light bulb is pulling from the source, from the power source, which could be a battery, a power socket, or whatever, whether it is AC or DC. That's where ammeter comes in. So for example, we have a battery, right? This is our battery, and we have a light bulb. This is our light bulb. How do I even draw light bulb? Who can manage this? This is our light bulb. Our light bulb is connected to this battery, and it is working. Now we want to find out the amount of current this light bulb is pulling from this power source. That's where this ammeter will come in. Now the ammeter will not just go and connect like the voltmeter would, as you are seeing here. This would not work. So for this ammeter to find out the amount of current this light bulb is taking, it has to be in series with the light bulb. So this ammeter, one of the terminal will go to this end. I'll need to draw this properly. Hold on, let me get a wiper. I think I should have one. So this is our circuit. Okay, let me not close it yet. So for us to find the amount of current now, the ammeter would go here, and the second probe would go over to this end. So you see the ammeter is now being connected in series with the load, right, with the circuit. This way, that amount of current this load is pulling from the source will have to pass through the ammeter, and that's how the ammeter will be able to read the amount of current being demanded from the load. Let me give you a simpler drawing. So this is our battery. This is our battery. This is our light bulb, right? This is our light bulb. This is already connected here. Then our ammeter will be sitting over here. This will give us the amount of current being demanded from this light bulb. If you want to check the voltage, maybe you want to see the voltage drop when you put this guy on, which means you are going to introduce a switch, so you could put it on and off. So we'll have a switch here. So this could go off and on. And we also want to see the voltage, right? So we'll have our voltmeter over here. Our voltmeter will now go in parallel with the power source. So when this is open, there is no current flowing, so this will be 0. This will be reading the voltage of the battery. Now, when you put this on, current will start flowing. This will start measuring the amount of current flowing through the circuit, and this will also measure the voltage drop of the battery, because you are not demanding something from it, you are taking something from it, so the power will start dropping. You can capture this from here, and when you now put this and this together, you will not get what? You will not get power, which is wattage. I will show you how to do that on the next video, because this video is already getting too long.